In this video, I'm going to go through some of the problems you posted online. The first problem is cobalt-60, which has a half-life of 7.7 years, used in medical radiology. A sample of 79.7 milligram of the material is present today. We are supposed to write an equation to relate the amount of cobalt-60 remaining after T years. So to write the formula, we know that the amount is equal to the initial amount times the half-life, which is 1/2, the base. And since we want to express it in terms of T years, so it's going to be T divided by the half-life. I represented T of 1/2. Now, based on the problem, I don't know what a 0 is, the initial value, but I know the half-life is 7.7 years. The next part of the question says, what amount will be present in 18.6 years? Again, writing the equation, A is A0 times 1/2 T divided by 7.7. What amount will be present in 18.6 years? We know that the initial value is 79.7, 1/2. The time is 18.6, so I can write this one as 18.6 over 7.7. If you simplify this one using your calculator, you get around 14.94 milligram. The next part of the question says, approximately how many years will it take for the amount of cobalt-60 to decay to 18.7% of its initial value? The initial value was 79.7, so the future value or the amount has to be 79.7 times 0.187. 0.187 is the decimal equivalent of 18.7%, which is division by 100, and it has to be equal to 79.7 1/2 T divided by 7.7. Again, this is the initial value. This is 18.7% of the initial value, and from here we have to find T. We said it before that the easy way of solving exponential equations is using the log function. First, I simplify 79.7 from both sides, so I get 1/2 is really 0.5. Exponent T divided by 7.7 is 0.187. I take the log of both sides, I get T over 7.7 log 0.5 is equal to log of 0.187. Then I divide both sides, or first I multiply by 7.7, so I multiply this guy by 7.7 and this one by 7.7, so I get T log 0.5 is equal to 7.7 log 0.187. Now what I'm going to do, I'm going to divide both sides by log 0.5. So T is equal to 7.7 log of 0.187 divided by log of 0.5, which is approximately 18.6 years. So this means that it will take about 18.6 years for cobalt-60 to to decay to 18.7% of its initial amount. The next question says Jaden wants to invest some money in an account that pays 1.6% annual interest, compounded semi-annually. She wants to have an accumulated amount of 684. So this is the future value. We do not know the initial amount that she is going to deposit. And also we know that she wants to have 684 after 8 years. Write a formula to represent A in terms of time in years. We know that in general, A is equal to A0 times 1 plus I exponent n, where A is the amount, the future value, A sub 0 is the initial amount, I is the interest rate, okay, compounded, and n is the number of compounding periods. Now, to write the information in this equation, because we have to write the formula to represent A, so I have to write A is equal to A sub 0. We don't know what is the initial amount. This is the future value. Times 1 plus the interest rate is 1.6%. In decimal is 0.016. Now, because the compounding is semi-annual, we always divide it by 2. And then because we have to express it in terms of years, let's say t, then we are going to multiply the time by 2, which is our compounding period. So this is the equation representing the future value. The next part of the question says determine how much Jaden needs to invest today, meaning the initial amount, in order for her to reach her goal in 8 years. So again, we are going to rewrite the formula. We found that the formula is A is equal to A0 times 1 plus 0.016 divided by 2 exponent 8 years. So we say 2 times 8. Now we know that the future value, meaning A, has to be 684. So we say 684 is equal to A0 times 1 plus 0.016 divided by 2 exponent 16. Now I divide both sides by this bracket here, so I get A0 is equal to 684 divided by 1 plus 0.016 divided by 2 exponent 16. This is going to give me approximately $602.13. So she has to invest $602.13 today, so she can have $684 in 8 years. The next part of the problem says, how much less would she need to invest if the financial institution were to offer her 4.3% semi-annual interest? Now, in this case, the formula becomes A is equal to A0, 1 plus the interest rate now is changing to 0.043. The decimal value is 4.3%. The compounding is the same, which is semi-annual, so we divide it by 2. And the number of years is the same, which is 16. And the number of years is 8. 8 times 2 is 16. Now in this case, A value is again the same thing, which is 684. Is A0 times 1 plus 0.043 divided by 2 exponent 16. Again, I divide by this bracket. I get A0 is 684 divided by 1 plus 0.043 divided by 2 exponent 16. This gives me approximately 486.68. Now the difference between what we found before and this one is the amount that she's going to save. So the amount that she's going to save is 602.13, what we found previously, minus 486.68, which is approximately $115.45. The next question that we have to solve is to solve an exponential equation. The equation is 8 exponent 3y plus 2 minus 9 exponent 4y is equal to 0. To solve this one, I'm going to move this to the right. I get 8 exponent 3y plus 2 is equal to 9 exponent 4y. To bring the exponents down, I'm going to take the log of both sides. So I get 3y plus 2 log 8 is equal to 4y log 9. Now I have a linear equation in y. To solve it, I'm going to move this one to the left, and I'm going to distribute this inside the bracket. So I get 3y log 8 plus 2 log 8 minus 4 log 9 is equal to 0. Now, 4y, here. Now, this one and this one has y in common, so I factor out y, so I get y 3 log 8 minus 4 log 9 is equal to negative 2 log 8. I move this to the right and change the sign. Now I divide both sides by this bracket here. So I get y is equal to negative 2 log 8 divided by 3 log 8 minus 4 log 9. If we use our calculator, this is approximately 2.45.